Well, hi, good morning. It's April 28th, another gray, rainy day here today. So I'm going to be setting this project aside, and I'm going to explain why, and then I have a good reason for you to hang on and keep watching this video, because I have some really interesting tubes here I'm going to show you as a consolation prize for having watched the, I don't know how many videos I did on this radio to get to this point. But I also want to explain why I think my thinking was defective about how to get around the problem here. What is the problem? The problem is I've got a speaker that's come from another radio and I'm using on this radio, and it's not the same. That speaker has a high resistance field coil, 1700 ohms plus, and the radio is looking for a 600 ohm field coil speaker. So I thought, well, I just bypass it with some resistors, and eventually even tried to bring it right to 600 ohms. And in every case, whatever I did ended up overheating the resistor. There's my last attempt there. Overheating, way too hot. Rather than continue this, I have my circumstances have changed here since yesterday. Yesterday I took delivery of about more than a dozen radios, most of which are going to come in the shop here to be fixed up. And I'm pretty sure of success with all those radios. I'm not so sure with this one because I haven't shown you the cabinet. The cabinet's not in great shape, and the grill cloth is shot. A couple other problems with that. So ultimately, even if I get this fixed up and working properly or good enough, I got this whole cabinet problem too. So I got this on my bench more or less because I didn't have something else to do, and I thought this wouldn't be what it turned into. Now, false thinking. What was my false thinking? So my thinking was I can cool off that speaker. I can cool off the speaker by bypassing some of the current. It's false thinking, I think. So here's how I'm going to show it to you here. Using the right end of the pencil. So picture a tall container of water, very, very tall. There's the water. And picture a hole down here. There's a hole, and water coming out of it. So let's pretend this is the power supply in the radio, and this water is the current going through my speaker. So I say, well, if I want less flow here, I should open up some more holes here and here and maybe another one here and let the flow come out. Now, do you think that would work? If you maintain the water at the same height, so the pressure's the same all the time, would cutting more holes in here help? And I'm sure the answer is no. It wouldn't, and that's what I've been kind of doing here. I keep cutting new holes, new water comes out. Better for the rest of the radio, but not really affecting the temperature of the speaker. I've never actually checked that, but I suspect it didn't do anything to the temperature of the speaker. And I've just had a way to fry bacon in here all this time. So you can't, well, supposedly it's been done before. You can bypass a speaker with a resistor and all that kind of stuff. I just couldn't make it work because there's just too much current and too much heat and too much everything. So now I'm going to show you something else. You've probably seen a diagram something like this before when you were in school. And the teacher probably told you something like, if you cut a hole a quarter of the way up, half the way up, and 3/4 of the way up, okay, so the water level would actually be something like that. Then you get a flow that looks like this. Do you remember being shown this? I remember being shown this. So the bottom one with the highest pressure is the one that shoots the farthest, even though it's closest to the ground. But you know what, that's not right. That's not actually what happens. If you actually set this up, what actually happens is this one falls here. It's the middle one that shoots the farthest. Now you can find this incorrect diagram in textbooks, and well, maybe not today. Some time has gone by since I was in school. But I wouldn't be shocked if the same story is being told incorrectly. So there you are. I straightened your head out on that, and now we're going to look at some Unusual vacuum tubes. Part of what I acquired yesterday was a tub of filthy, dirty vacuum tubes, which I spent some time cleaning before even examining them. And I brought a few in here, which I think are pretty interesting. Let's start with this one. Okay, so this is a 83. Don't know if it works. Don't think it does. I haven't tested it or anything. Made for Westinghouse, made in the USA. So when you look at it, if you look right through the glass here, you see something on the other side over here. That's the remnants of the getter. You see, and they look at the tube, there's no getter, right? There's no silver patch. Where's the silver patch? Have you seen it? This is the remnants of the patch, the getter. Here. Now, if you look, you see something flopping around inside the tube. Whoops. What is that? Yeah, I'm not absolutely sure, but that might be the getter having peeled off the glass. Oh, no, 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 no. It's come from here. It's come off of here. Oh, I didn't notice that before. So I'm pretty sure this is just a rectifier tube. I said it was an 83, so it looks like an 80. 80s look like this. Maybe an 83 is a slightly different version. And why would this piece have come off? I guess maybe overheated, or that's just what happens after years and years. I don't know. What about the getter? So I think the getter's been gotten. It's been consumed entirely. And so this is probably a gassy tube. It's probably what's happened. The getter continues to collect gas through its life, but it has to be hot to do it. Now, look at this unusual tube here. This is a General Radio Type 631 P1. You look inside it, it doesn't look at all like your usual tube. This is a graphite ring here, which is going to act as a grid on this tube. It's filled with neon, or has neon gas in it. And the way this works, you put a high voltage, I'm going to probably play around with this at some point. You put a high voltage between the cathode, I don't think there's a heated cathode, just between the cathode down here and the anode up in the top. You put a couple hundred volts there, then you raise the potential of the carbon grid here, graphite grid. When you get up around 70 volts, a release of current takes place through the tube. Apparently, you're using some capacitors to enable this, but the pulse is so fast, so much current goes, it's hundreds of amps or something crazy like that in just a flash, like a tenth of a microsecond or something, and it releases a vast amount of light like that. So it's a strobe light. It's basically a strobe light. Can you hear that? I'll hold it up near the mic. I'm sure you can hear that. So something's rattling around, but it's probably actually down inside here. I don't think it's rattling around inside the tube itself. But just like that other tube, it's not uncommon. Sorry, I keep holding this out of view of the camera. It's not uncommon for debris to be loose inside the tube. Here you can see the getter is still shiny, still intact. Looks a little thin through here. Is that what happens? Thins out? Turns white. Okay, now this tube. This one kind of floored me. I mentioned these tubes are really dirty, and I was cleaning them very carefully, and part of that was to try to detect where the name is and not wipe it off. You probably can't read this. Maybe you can. It says Nippon Electric. Nippon Electric. Nippon is a nickname for Japan, or another name for Japan. See, it says NEC KX80. And then at the very bottom here, I can't quite read it. So the thing is, this is a Japanese tube. It's a Japanese tube from 1924. This is a 100-year-old tube. They were making these in Japan 100 years ago. I didn't know that. I didn't know Japan was doing this kind of stuff. But you shouldn't be too surprised. Japan's always been a highly technical society, very productive technical society. So anyway, I've never seen a Japanese tube, especially one 100 years old. Now, so looking at this one, I have a bunch of these. Some of the radios came with a box of tubes, which was just handed over. 310A. So CGE, which stands for Canadian General Electric. Distributed by Canadian General Electric, Toronto, Canada. A quality product. Electronic tube. Un product de qualité, USSR. What? USSR. Now it's French here. This is the French side. You know, Canadian products usually have a French and an English side. That's French. But on the English side, whoop, they managed not to say made in USSR. USSR. When? Look at this. Okay, so I'm pretty sure this is an NOS tube. It kind of pins on it, dates it in the mid-20s to the very early 30s. It's a 310A. USSR. They're just floored that this would be here. Up here it says also, made in USSR, right on the glass. Well, we all know, of course, the USSR is a highly technically competent country, and the fact that they're making tubes, they still make them today. But back in the 30s, Canadian General Electric was contracting with a Soviet factory. I showed that to my wife and her eyes popped out. Now the last thing I'm going to do on this little journey here is we're going to travel back in time. So this is a tube that I believe has never been taken out of the box until I did it yesterday. In the course of doing that, I split the box because the box is not strong. Westinghouse, Canadian Westinghouse, what it says there. Notice licensed only to extent indicated on the enclosed instruction sheet. Oh, enclosed instruction sheet. Radiotron, it's a UX 171 power amplifier. It's worth some money actually. These old tubes are worth some money. Let's open her up here. Oh, somebody wrote okay on there. Well, tube's okay. This could be an old tube that's been stuck back in, but look at the way it's packed in here. Wow, it's pretty horrible, isn't it? Oh, yeah. Well, I'm telling you, these tubes are just a mess. Where they've been exactly, I don't know. So here's the tube. Oh, and that doesn't look like it. This looks like it's come out of something. On these old tubes from the 20s, the tube name is up on the top here, but I don't want to wipe it off. It looks like it's partially missing. But it probably is what it said on the package. Here's the interesting part though. I saw this and I didn't want to go any further. This. Oh, 227 on here. This says 171. Well, so much for this being I thought this was a virgin package I was opening. No. Read carefully, it says. The Radiotron UY227 is a general purpose tube containing a heater element which permits operation from alternating current. It is designed for use either as a detector or as an amplifier in AC radio sets, operating from the light socket. Operating from the light socket. So if you go back when this tube was being manufactured, is there a date on here somewhere? There probably is. This is the guarantee here. Show you they put a date on this somewhere. They don't appear to have. So back in the day when people were first getting electricity, sometimes the only thing you got was a light bulb. A light bulb and a socket to screw it in. And this might be mounted on your wall, or it might be hanging from your ceiling. And that was the light. And people were excited. But then what if you wanted to plug something in? Well, you'd have to unscrew the light bulb. And then you screw in this little plug thing, and then you've got a plug. You get no more light. Hopefully you can still see enough. Then you can plug in your radio, or whatever it is. So it's actually written right here. That's how common this was. Operating from the light socket. I guess they didn't need, they must have had outlets on the walls then. Or a one outlet, I don't know. Heater voltage 2.5, heater current 1.75 amps. Detector plate volts 45, that's all. Amplifier plate voltage 190, grid voltage minus 13.5. The heater in this Radiotron should be operated at its rated value of 2.5 volts. The plate voltage of 90 volts used with a negative grid voltage of 4.5 or a plate voltage of 135 used with a negative grid voltage of 9 is recommended for general amplification either in the radio frequency stages or in the intermediate audio stages. Intermediate audio stages. They wrote intermediate with italics or italics. For the last audio stage, a power amplifier Radiotron is recommended for the best loudspeaker results. If, however, Radiotron UY227 is used, 180 volts may be applied to the plate and negative 13 volts to the grid in order to avoid distortion. In some circuits, biasing of the heater approximately 9 volts negative with respect to the cathode may be beneficial for best operation. A heater cathode bias higher than 9 volts is not recommended. Additional information on this Radiotron is given in Technical Bulletin UY227. Ask your dealer for a copy of it. Handle the Radiotron carefully. This is a diagram of, I think, the base you're plugging it into. Canadian Westinghouse Company Limited, Hamilton, Canada. I don't think I'm going to read the whole guarantee, but what are they guaranteeing? This Radiotron is guaranteed to be free from electrical and mechanical defects. It has passed the most rigid test before shipment. In bold print here. If this Radiotron does not give service, you have a right. I'm sorry, let me read that again. If this Radiotron does not give the service you have a right to expect, please return it to the dealer from whom it was bought for test and examination. Please tell the dealer the make of the radio set in which it was used, and the voltages at which it was operated, and the circumstances under which it failed to give success. To give successful and satisfactory service. In other words, admit it, buddy, you blew the tube yourself, and you're not going to get away with it. And then here's the fine print. I will not read the fine print, because it's just legalese. Well, I'll read the very bottom one. This device is licensed for no other use unless, by special written contract of sale with Canadian Westinghouse Company Limited, the purchaser has agreed to use it in some other special manner only as set forth in the contract of sale. The right to employ the device in such a special manner is not transferable except by special agreement with Canadian Westinghouse. What were they so worried about? Somebody was going to do something weird with their tube? Somebody was going to make an invention using their tube and they weren't going to get a cut? I don't know. Well, it's pretty demanding that you're going to go down to the store and you're going to tell the guy what voltage you had on the plate of the tube. Now, how many people could have possibly done that? I don't know. Maybe at this time anybody who was, had a radio also knew all this stuff, because radios were so what's the word for that? Something that requires an awful lot of attention to make them operate. Well, that's it. So tomorrow, so I'm going to put this radio back out. I'm not abandoning this totally. It's just going on the shelf where it's been for quite a while. It's going to go back there. And maybe along the way I'll acquire another speaker, because the real solution is to get the correct speaker for the radio. And I'll have something else in here tomorrow. It's going to be just a regular, probably a 5-tube wooden radio from the 30s or 40s or something like that. And stay away from these big monsters. Well, all the string work I did on this guy, even though one of them is backwards still. Yeah, it's tough. It's tough for me to walk away from something like this. But then I'm telling myself I'm not walking away. It's just going into abeyance for a period. So thanks a lot for watching. Hope you enjoyed the tube show. And tomorrow we'll start another radio. I feel better.